Imagine for a moment that you were looking at a family photo. You see your siblings, your parents, your cousins, you all share a resemblance. But then you look at a photo of the entire human population and you realize something terrifying. Your family looks nothing like anyone else. You are the anomaly. You are the exception. This is exactly the existential crisis astronomers are facing right now regarding our own solar system. For decades, we believed that the way our Earth, Mars, and Jupiter formed was the standard blueprint of the cosmos. We thought we were the rule, but recent data has shattered that illusion. We are not the rule. We are the freaks of the galaxy. There is a type of planet, a specific class of world that dominates the Milky Way. It is the most common planetary architecture in the universe, appearing in star system after star system. And yet, look around our solar system. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Do you see it? No, we don't have one. We are missing the single most important piece of the cosmic puzzle. But today, everything changes. As per the latest reports coming in, experts are finally piercing the veil. For the first time, we aren't just guessing, we are getting a direct look at how the universe builds these mysterious worlds. This discovery doesn't just change our map of the galaxy, it challenges the very physics of planet formation we have taught in universities for 50 years. But here is the truly disturbing part, which nobody is talking about. If these planets are the most common and we don't have one, what does that say about the rarity of life on Earth? There is a specific mechanism, a violent, chaotic process that prevents these planets from becoming Earths. What is that mechanism and how did we survive it? I will explain the terrifying precision of this cosmic filter later in this video, because understanding it is the key to understanding why we are here at all. Welcome to the Deep Dive. To understand the magnitude of what has just been revealed, we first need to understand the architecture of anomalies. When we look at the United States or any nation on Earth, we look at demographics to understand the average citizen. In the galaxy, the average citizen is not a rocky Earth, nor is it a gas giant like Jupiter. It's something in between. Astronomers call them Sub-Neptunes. These are planets that are larger than Earth, but smaller than Neptune. They usually possess a radius between 1.6 and 3 times that of Earth. In the Kepler Space Telescope surveys, and now with the TESS mission, these things are everywhere. They are the galactic standard. So, the big question that has plagued NASA and astrophysicists for years is how are they built, and why did our solar system stop building? The new data we are analyzing today gives us a front-row seat to this construction site. The universe builds these planets through a process that is far more dynamic and aggressive than the slow, gentle accumulation we once imagined. Traditionally, we believed in a model called core accretion. Picture a young star surrounded by a disk of dust and gas. Slowly, over millions of years, little rocks smash into each other, sticking together like dust bunnies under your bed. Eventually, they get big enough to pull in gas. It's a slow, polite process. But the new insights suggest something different for these sub-Neptunes. It appears the universe utilizes a pebble accretion highway. Instead of waiting for rocks to smash, these planets form by rapidly inhaling huge streams of pebble-sized particles, millimeters to centimeters in size, that drift inward from the outer reaches of the star system. It's less like building a house brick by brick, and more like standing in a blizzard and having the snow instantly freeze onto you. This speed is crucial. Because they grow so fast, they migrate, they move, they don't stay where they were born. And this brings us to the green matters aspect of the discussion, the environment. When we analyze the atmosphere of these common planets, we aren't just seeing rock, we're seeing thick, oppressive envelopes of hydrogen and helium, or in some cases, massive, deep water worlds. Let's analyze the water world theory, because this is where the US audience needs to pay attention. It changes the hunt for extraterrestrial life entirely. For years, we looked for Goldilocks planets, Earth clones, but the data indicates that many of these sub-Neptunes might be Hycean worlds. This is a portmanteau of hydrogen and ocean. Imagine a planet completely covered in a global ocean, hundreds of kilometers deep, deeper than the Mariana Trench could ever dream of, topped by a thick, steaming atmosphere of hydrogen. The pressure at the bottom of these oceans would be exotic ices, specifically Ice 7, a crystalline form of water that exists only under crushing pressure. But near the surface, it could be warm. It could be stable. However, the report indicates a construction flaw in these common worlds, and this connects back to the hook, the danger I mentioned earlier. The universe seems to build these planets right on the edge of a precipice known as the Radius Valley. When we look at the size of planets in the galaxy, we see a gap. We see lots of super-Earths, rocky big Earths, and lots of sub-Neptunes, gassy mini-Neptunes, but we see almost nothing in between. Why? The leading theory, which is being bolstered by these new observations, is atmospheric stripping. These planets form quickly, grabbing on to that hydrogen envelope, but then their host star wakes up. Young stars are violent. They flare with X-rays and UV radiation. If a sub-Neptune forms too close to its star, that radiation blasts the atmosphere away. It boils the planet alive. What you're left with is the stripped core, a naked rock, a super-Earth. If the planet forms a little further out, it keeps the gas and stays a sub-Neptune. This means the most common planets in the universe are the survivors of a cosmic torture test. They are either the ones that held on to their suffocating gas blankets, or the ones that had their skies ripped away by stellar fire. Now, let's step back and analyze the implication of this construction method for our solar system. Why don't we have one? There's a theory called the Grand Tack Hypothesis. It suggests that Jupiter, our massive gas giant, formed early and migrated inward toward the Sun, plowing through the material that would have built these super-Earths or sub-Neptunes. Then, caught by Saturn's gravity, Jupiter tacked like a sailboat and moved back out. In essence, Jupiter might have destroyed the construction site of the common planets, leaving behind just enough debris to form 4 small, puny rocky worlds: Mercury, Venus, Earth, and Mars. Think about that. If this analysis holds true, the reason you and I are here, breathing nitrogen and oxygen on a tectonic plate, is because Jupiter acted as a wrecking ball billions of years ago, preventing the formation of the standard planetary type. We are the beneficiaries of a cosmic delivery job. But let's look at the green matters perspective found in the reports. Why are experts finally getting this look now? It comes down to the resolution of our new eyes. Instruments like the James Webb Space Telescope and ground-based interferometers are allowing us to see the chemical fingerprints in the protoplanetary disks, the birthplaces of these planets. We're seeing water vapor, we're seeing carbon monoxide, we're seeing the ratios of these chemicals, which tell us exactly where the planet formed. If a planet has a lot of carbon relative to oxygen, it likely formed far out, past the snow line, where carbon freezes solid. If it has less carbon, it formed closer in. The current analysis suggests that many of these sub-Neptunes form far out in the cold dark and then migrate inward. As they move, they bring volatile materials, water, ammonia, methane, into the habitable zone. This is a double-edged sword. On one hand, it delivers the ingredients for life. Water is essential. On the other, if they migrate too far, they become hot Neptunes, sterilized worlds where nothing can survive. Now, remember I told you at the start of the video that I would tell you what could happen, the specific consequence the audience needs to know? Here it is. The data suggests that the transition from a sub-Neptune to a super-Earth isn't just a physical change, it might be the biological filter of the universe. If the universe builds sub-Neptunes by default, and if life requires a rocky surface with a thin atmosphere, like Earth, then the vast majority of planets in the universe are basically failed Earths. They either have too much gas, suffocating any surface life under crushing pressure, or they have been stripped bare by radiation, sterilizing the surface. We exist in the improbable middle. The Earth has an atmosphere, but it's a thin veneer, not a crushing blanket. We have water, but we aren't a water world drowning in 1,000-kilometer deep oceans where nutrients are locked away in ice. This new analysis of planet formation suggests that the standard model of the universe is hostile to technological life. A sub-Neptune with a thick hydrogen atmosphere might host bacteria. It might even host swimming creatures in those deep, dark oceans. But think about it. Can you build a fire in hydrogen atmosphere? No. Can you smelt bronze or iron underwater? No. If the most common planets in the universe are sub-Neptunes, then the most common life in the universe might be aquatic, trapped under layers of ice or gas, unable to ever see the stars, unable to ever build a radio telescope to call us. This is the Fermi Paradox staring us in the face. Where is everybody? Maybe they're all trapped on the most common planets, locked inside aquariums designed by gravity. This brings us to the geopolitical and economic angle. Why does the US audience, or indeed the human race, care about this specific scientific advancement? Because we are currently in a new space race. It's not just about planting flags on the moon, it's about understanding resources and habitability.
If we eventually become an interstellar species, we need to know what real estate is available. If 80% of the available planets are sub-Neptunes, we need to figure out how to handle them. Can we terraform them? Can we strip away that hydrogen layer artificially to reveal the rocky core underneath? This research is the baseline for future human expansion. We are mapping the wilderness before we step into it. Furthermore, this analysis of pebble accretion and disk instability helps us predict solar weather and solar system stability. It validates our computer models. If we can't simulate how a planet forms, we can't simulate how a climate changes. The physics is connected. To wrap up this analysis, what we are seeing today is a fundamental shift in our cosmic self-awareness. For centuries, we thought the Earth was the center of the universe. Then we thought the sun was the center. Then we thought our solar system was normal. Step by step, science has humbled us. We now know that our home is a quirk, a bizarre arrangement of rocks and gas that defied the statistical odds of the galaxy.